Okay, yeah. We're gonna kind of cheat a little bit here. Have any of you guys ever heard of this idea of using magnets for medical care?
No.
You heard magnets are bad for you?
I heard that too. Same. If you eat them.
Well, you're not supposed to eat them. Yeah. That's a really bad idea. Yeah.
What happens if you eat one?
It can disrupt, like,
There's like
because if you have more than one and if they're at different places in your digestive tract, they'll attract to each other. It's a really bad idea. Yeah.
Oh, I see.
Yeah. You don't. Yeah. But hey guys, remember when I said that we're recording and we want to be on our best behavior? Like, it's not going to shock Luke that we're having this conversation, but yeah. Hey, so my first question before we get started on this is, am I allowed to directly compare this person who was wearing an inactive magnet? And guys, the basic premise is this is the people's pain reading, that the magnets are supposed to help decrease pain. Okay? And am I allowed to directly compare this person and this person? They are not the same person. No. There's nothing that connects them. So this would be a 2-sample T procedure that we're going to do. We're going to do a 2-sample T test. Okay? If I could directly compare those individual operations, or individual observations, not operations, okay? If I could directly compare them, that would be a paired T procedure, okay? And as promised, one of the questions on your test on Friday, you will be given the you're going to be given a question in which you're going to have to decide, should you be doing 2-sample versus paired, okay? And what you want to ask yourself, again, is can these two numbers be directly compared to each other versus collectively as a group instead? Everybody good? All right. Now, so we have 2 different types of treatment groups here. One group is getting magnets that are active magnets that actually work, and some are getting basically placebo magnets, okay? All right. And we see this phrase, statistical evidence, which tells us we want to do a test and get a low p-value, hopefully. Okay? All right. What do you guys want to do first?
2-sample t-test.
2-sample t-test for? I'm going to do mu A minus mu I. Let me tell you why. But even so, like, if you use those, like, distinguishing subscripts, I have seen some rubrics, not all of them, but some of them, if you, for a 2-sample procedure, using those subscripts is enough for defining the context. Not all. So, like, I'm going to grade you on the toughest rubric to set, like, the right habits, right? But I have seen rubrics that do that, and it's just another way to get you credit for something that you might
have to define.
I'm still making you do it. But let's say you forgot to do it, using the subscripts is more likely to get you credit than using a 1 or a 2. Okay? All right? And so now what? Define them, okay? So mu A is the true mean pain rating for active magnets. Mu I is same for inactive. Okay, what next? State your hypotheses. Well, what are they? Mu A minus mu I equals 0.
Could you just say that they're equal?
Yeah. mu A minus mu I. If the magnets work, should the active be higher or lower pain ratings? Lower, so less than 0, yeah?
Can you just write that as equal and then less than? Or, oh, wait, never mind.
That's what your hypotheses would need. You could write it as or mu A equals mu I and mu A is less than mu I. Yeah. Okay. Okay. Conditions. Random. Is the random condition met?
Yeah.
Wow.
Probably says it somewhere in there.
Random selected of random magnet selection.
I feel like it's not actually random selected of that.
It says random selection.
A magnet from a pile. So the treatments are still randomly selected.
Oh, yeah.
The being the okay. Normal? All right. So one, you guys we're not drawing this graph, don't worry. Okay? Are you aware that you would need to draw a graph on the AP exam or on your test?
Yes.
Okay. Now, with n equals 21 and n equals 29, you would not need a super, you wouldn't need to show mound-shaped or anything. You would really just need to show no outliers, yeah? Because those are so darn close to 30. Is everybody with me? Okay? Now, it just so turns out that me being the gracious and magnanimous teacher that I am, you guys agree with that, right? I went ahead and already put all of these into my calculator so you wouldn't have to type them all in.
Thank you, Meister.
Oh, okay. And what I want to show you is, so if you look, I have them entered into my L1 and L2. Okay? Let's say this was the AP test and you didn't want to draw a dot plot, 2 dot plots, by the way, both which with lots of variables on it, right? Okay? You could use your calculator to sketch the box plots of them. So I want to remind you how to sketch a box plot. Everybody good? So you guys can just follow along so that you don't have, because otherwise I'm trying to make it so you don't have to type this whole list of things into your calculator. You with me? Okay? But if you bring up second y equals to bring up the stat plot, yours is going to look a little bit different, but you can basically turn on plot 1. If you'll notice on my plot 1, okay, it's going to be in blue. I've selected the box plot that doesn't connect to outliers. And it's of L1. So this is the active magnets list, is the blue box plot. Is everybody with me? All right. And then in my plot 2, everything's the same except for it's going to be red. And that's of L2, so that'll be the inactive magnets. Okay? But if you have the data in your calculator will make that box plot for you. Is everybody good? And it will not connect to any outliers. This is another way for you to check on outliers if you're trying to decide if something is outliers. Okay? So now if I do Zoom 9, which is the Zoom stat graph, it automatically fits it. There you go. Do either of my box plots show outliers? No, because the outlier would be graphed as a freestanding point. And we could actually just sketch these 2 box plots to do this. You with me? That would be a sufficient thing. I'm not even going to do that for time reasons because I want you guys to have time to work on your homework. Okay? But you can say no outliers on the box plots.
So would we have to sketch the box plots or could we just write?
Yeah, you would still have to sketch them. But your calculator also gives you your 5-number summary, or you can hit trace. And notice that when I hit trace, it's telling me the min of the blue graph is 0 and the min of this red graph is 4. If I hit over, it'll give me the quartiles. I'm surprised it's not giving me, that's so weird. Yours, I think, will give you all of them all at once, or it might give you, you might have to go up and down between the graphs, but it'll tell you those values. Cool? Everybody good? All right, now, we also need to, do the calculations. Right? That's our next step. Okay? I'm sorry. Oh, independent. You're right. When you're right, you're right. Hey, you guys, how do I meet the independent condition? It's not the treatments, it's the responses. Individual pain ratings are independent.
So, what if they were the same person? Would that make it
That would make it a paired t-test.
But what would you say for independence?
Same thing.
Well, are they still?
Well, it would be the individual changes in pain ratings would be independent.
So with the paired t-test, you're just putting it into the t-test and just doing the differences? Whereas this,
You're choosing 2 sample t-tests.
is there also a paired t-interval?
We've done paired t-intervals. Okay. But so if so that's why the t-test on the calculator is not paired t-test and 1 sample t-test, right? It's both. You should think of it as a t-test on 1 set of numbers.
Yeah.
You're good. And I will be done actively teaching in 10 to 15 minutes if that will be if that'll be helpful to you guys in any sort of way. It's a long story, but essentially all the CCP psych or soc or somebody is using this room to test tomorrow during lunch. And they're counting the tables / maybe bringing in more tables for everybody to fit. Okay. Are we ready to do some calculations? Okay, we go to stat, we arrow over to tests. Does anybody want to guess which one we want to choose? Number 4, perfect. And at this point, what we have is the raw data. Again, you guys don't need to type this in. I didn't give you any of the summary stats, right? So unless you guys want to type them all in. Right, I did it for you because I am a magnanimous teacher.
What does magnanimous mean?
Let's practice using context clues, Blake. Does anybody want to guess what magnanimous means? Giving. Someone who gives a lot of themselves. Magnanimous. Hey guys. Are you guys cool? Won't you guys check, how did I put this in? Did I do a good job or not?
Yes. 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 Is your L1? Yeah.
The actives were in L1. I did okay? Cool. Now, what do I have to write down? Everything. All right. I like to start with X bar A, S A, and A, which is 4.345, 3.12, 29. And then X bar I is 8.43. 1.86. And guys, just want you to know if I left this as my answer as I currently have it, you would get an I in this section. Why am I getting an I in this section? Why is my p-value not allowed to be 3.05? It can't be above 1 because it is a probability. Times 10 to the -7. So when I've had, the reason I'm pointing this out is I have had students not see that times 10 to the -7th. I want us to recognize that I didn't do anything wrong because I got this 3.05. We didn't make a mistake. It's just that we didn't, that means we got to see that E -7. Yeah.
Do we have to write that, or can we just write 0?
If you write 0, that's probably going to be fine. I would say if it's like E -4, you should actually move it over. But once it's past -4 or -5, I think you're okay calling it 0. Especially if you used approximately. Yeah. Okay. Cool. We're almost done. Since.
Just for the degrees of freedom, you did say like there's no situation where we have to find that, right? Unless it's like a simple 1 minus or n-1, right?
Correct. But even so, if it's something like this where you're just running the test, that answer is no, you won't have to do it.
Yeah.
If it were like a multiple choice question, you could run it and then just pick which one matched. Or sometimes what they'll do is if they want to talk about it like really, really old school, before the calculator did all those calculations, they just used whichever sample size was smaller as your degrees of freedom, right? So in this case, it'd be 20 in this case, yeah. But that's so archaic in terms of how this stuff is done now that I don't think it would be something that they'd put on the AP exam. So, hey, you guys, is that bigger than or less than 0.05? Much less than 0.05. Cool. We can.
Reject the null.
Do you guys remember, like, 6 weeks ago when I first introduced the process of rejecting or failing to reject the null, and how terrified you guys hated it so much? Now, are you feeling pretty good about it? Therefore, we can conclude. What can we conclude?
The true mean pain rating for active magnets is less than that of inactive.
Hey, you guys, does that mean that active magnets caused the decrease in pain ratings? We have random assignment. We can, in fact, conclude cause and effect.
Even though.
Everybody good? All right. Lastly, for both of these, these two examples, I just want to make sure we spend a little bit of time talking about. Sorry, I saw some of you were still having that down. Talking about whether each of these would be paired versus two sample. do you guys think? Huh? Go ahead and read it. Yeah. I don't imagine that you're going to think about it until you have read it. Yeah?
I think we should do that, but that should be not paired.
The first one?
I think it's paired.
First one should be
Paired.
Because it's the same car.
But because
The car is the same.
because they are on the same car, it is okay to directly compare them to each other. I would call this paired.
I think the second one's too simple.
The second one is too simple. All right, I got one more I want to ask you guys, okay? Let's say that Mrs. Turner and I want to decide which one of us does a better job preparing our students for the AP exam. Everybody good? Now, a huge lurking variable would be that they are two very different exams and one might be more challenging than the other, right? So this is what we decided to do. I'm gonna pick out who is my highest student. She's gonna pick her highest student. Okay? Then I'm gonna pick my Q3. Then I'm gonna pick my median, my Q1, etc. Is everybody with me? Can I directly compare the individuals in the sample in that case? You absolutely could. Because what pairs those two together?
Is their positioning.
Their position in the class, their rank in the class.
But what if the person in stats sucks a lot worse than the person in calc sucks worse? Like, you know what I'm saying?
I do understand what you're saying, yeah.
The worst person in stats is really bad, and the worst person in calc is like bad.
Well, so you would be the worst.
But like, why can you still compare them?
Because we're not comparing the because they're not individual students at that point. They are lowest, Q1, median, Q3, and max, and you're comparing the teacher, not with the student's achievement. You're not comparing the students themselves, you're comparing their achievement. Or would you feel better if I said we both picked a student who finished the course with a 95, and then we both picked a student who finished the course with a 90, and then an 85, etc.? Would that make you feel more comfortable?
Yes.
Yeah, that does.
But then you run into some other concerns, because
She has a curve. You have a curve. She doesn't.
I use the curve and she doesn't.
And then is that getting rid of the whole like class positioning thing?
Also, she has a much stronger prereq than I do. You have to get like an A or B in honors pre-calc to take AP Calc. The prereq for this course is Algebra 2.
Could you compare, like, this is a different scenario,
Yeah.
like a basketball team that does tryouts versus another basketball team that anybody.
And maybe compare different positions. Sure. Sure.
Well, it's more selective.
If there is something that pairs them together, you could do a paired test. And I think sometimes we get obsessed with, oh, it's the same person, or oh, it's the same car. As long as there's something that it makes sense to compare the individual observations, it's paired. All right, I'm done.